In this example, we're going to use a probability density function to calculate some probabilities and find the mean of a distribution. So we're given the function f of x equals a constant k over x to the 3/4, where x is between 0 and 1, and otherwise it's equal to 0. The first question we're asked is what value of k makes f a probability density function. B asks us to compute the probability that x is actually greater than 16 over 81. And C asks us to find the mean. So to figure out what the k value is, we need to set the integral over the entire interval equal to 1. In this case, the only parts where f can be non-zero is between 0 and 1. So we have the integral from 0 to 1 of k over x to the 3/4 dx is equal to 1. We know that this is an improper integral, so we'll replace the 0 with a b and let b go to 0 from the right. That k is a constant, so I can pull it outside the integral and outside the limit. So I have the limit as b approaches 0 from the right of the integral from b to 1 of x to the negative 3/4 dx. That has to equal 1. An antiderivative for x to the negative 3/4 is 4x to the 1/4. Plug in our endpoints and we get 4 minus 4b to the 1/4 as our answer to the integral. Still have to take the limit. When we put in 0 for b, there's no issue, and we just get 4 for that limit. So we still have the k out in front, so we get 4k on the left-hand side. That was still equal to 1 all the way down, so we divide by 4 and find that our k has to be 1/4. For part B, we're asked to find the probability that x is greater than 16 over 81. Plug in 16 over 81 for our lower limit of integration. The largest x that we can use in our the probability density function is 1. So we're integrating from 16 over 81 to 1 of our 1 over 4 x to the 3/4. We found the k was 1/4. That's where that 1 over 4 x to the 3/4 comes from. Antiderivative for that is just x to the 1/4, and you plug in your values and simplify, and you should get 1/3. Finally, in part C, we're asked to find the mean. Remember, your mean is integrate over the entire interval, that interval from 0 to 1 in this case, of x times the probability density function. Sometimes we call that the PDF. Notice that technically this integral is improper because I cannot put 0 into the PDF. However, when we simplify the x with it, I get an x to the 1/4 over 4 that I need to integrate. And there's nothing improper about that, so I don't need to worry about going through all of the limit issues that we typically use to evaluate an improper integral. Antiderivative of x to the 1/4 over 4 is x to the 5/4 over 5. Plug in your endpoints and you get 1/5 for your final answer.